To solve this is quite simple. First of all, you need to understand pH. Okay, let's see. The first thing you need to know about pH is this: pH is mathematically expressed. To the layman, pH is simply measure of acidity and alkalinity. Did you get? But it is mathematically expressed as negative log to base 10 of the concentration of hydrogen ion. You know you can also use negative log to base 10 of the concentration of hydroxonium ion. You know that, right? This is pH. Good. Now that's point 1. Point 2 about pH is that if, for instance, you decide to do the opposite of pH, that is, you want to use pH to find concentration of hydrogen. Concentration of hydrogen, for those of you that know log, you will notice that the opposite of log is anti-log. Hope you know. So first of all, take this minus over. It becomes minus pH will be equals log to base 10 of the concentration of hydrogen ion, which is going to mean that concentration of hydrogen ion is equals anti-log of concentration of negative pH. Now, if you don't want to do this because you will not have a calculator that has log in your jam, what you basically do is you now do 10 raised to power negative pH. So which means if you want to do anti-log, concentration of hydrogen ion will now be equals 10 raised to power minus pH. So this is a formula you should take note of. So put this down. Okay, so I was saying something. I said if you are to consider the opposite of pH, that is, you want to make concentration of hydrogen the subject of formula, what you basically do is to do the anti-log of this pH. And when you do that, first of all, this negative has to go over. Becomes you have to divide both sides. The negative is not going over. You are removing the negative here by transferring it to this side. And how you do that is by multiplying both sides by minus. Do you understand? Okay, so that's why we have negative pH equals this. Now, if you are going to make this the subject, is either you do anti-log of that negative pH, or you use this 10 to raise the power, and you have concentration of hydrogen is equals 10 raised to power minus pH. Is this clear? Okay, good. Now, the next point you need to take note of is that concentration of hydrogen ion times concentration of hydroxyl ion is equals 10 raised to power minus 14. This is what we refer to as the ionic product constant of water. Constant of water. And it is product constant of water. And it is a constant value for every aqueous solution. Once you are dealing with an aqueous solution, the ionic product constant of water will remain the same. Is this clear? Once you are dealing with an aqueous solution, the ionic product constant of water remains the same. Is this clear? Good. Okay. Now, what is the next point? Oh, so which means if I ask you to find concentration of OH, what are you going to do? 10 raised to the power minus 14 divided by concentration of H, or when I ask you to find concentration of H plus, it's going to be equals 10 raised to the power minus 14 divided by concentration of OH minus. Is this clear? So imagine you are given OH concentration, for instance, but then you are asked to find pH. You will need to use this OH to find the concentration of H, then do the negative log of the H to get your answer. Did I confuse you? I said if you are given a question and instead of giving you concentration, you know, if you are solving for pH, you only use concentration of hydrogen. Hope you know. But what if instead of giving you concentration of hydrogen, they give you concentration of OH? So what do? You use this to find the concentration of hydrogen. You will now do 10 raised to the power minus 14 divided by the concentration of OH that they gave you in that question, and you get the concentration of H. Then put it here and get your answer. Is this clear? So where this happens is if they ask you for pH of a base. So when they ask you for pH of a base, what you do is you use the concentration of the base to find the concentration of the hydrogen. How? By dividing 10 raised to the power minus, or by that concentration of that base. If you do that, you will get the concentration of hydrogen, then put it here, get your answer. Hope this is clear. Okay, the fourth thing we need to take note of. Okay, let me take this out. If pH is greater than 7, alkalinity. pH less than 7, acidity or acidic. pH equals 7, neutral. Is this clear? Okay, good. Now remember, what makes an acid is the concentration of hydrogen ion. So if the concentration of hydrogen ion is greater than what makes a base, which is hydroxide ion, the implication is that this will be acidic. Hope you know. Do you understand? Is greater than the concentration of hydroxide ion. Acidic, correct? Yes. Good. On the other hand, if the concentration of hydroxide ion, which is what makes it a base, is greater than the concentration of hydrogen ion, what do you think it will become? Or alkaline. Then what if you have a situation where the concentration of hydrogen ion is equal to the concentration of OH minus? What is it going to be? Neutral. Thank you. And for that to happen, it means that the concentration of hydrogen ion is equals 10 raised to power minus 7, and the concentration of hydroxide ion is equals 10 raised to power minus 7. If you add these two things with that formula, conc of H plus times conc of OH minus, if you do it, what you are going to get is 10 raised to power minus 14, which is what we refer to as the ionic product constant of water. Is this clear? Good. So when this and this are equal, it means that it is neutral. And if you resolve this by pH, you will get your pH value for neutral solution to be 7. Is this clear? If you decide to, okay, let's say you have a question, they tell you what is the pH of this solution where concentration of hydrogen is 10 raised to power minus 7. Let's do it. pH will now be equals negative log to base 10 of the concentration, which is 10 raised to power minus 7. Now you already know that when you are solving for pH, what do? Negative log. This, one of the log rules is that if you have a power, this minus 7 will come in front and multiply the log. So this is going to be minus 7 times negative log 10, right? So pH is going to be equals minus 7 times log 10. Please, log 10 is 1. Do you understand? Log of a number to the base of that number, log 10 base 10 is 1. So which means log 1 base 1 is 1. So log 10 base 10 is 1. So this is going to be minus, remember minus is still here, so this is 1. So which means that the pH is going to be equals minus 7 times minus 1, which is equals what? 7. Thank you, sorry. Hope this is clear. Okay, good. So with that said, you've taken note of this. What number is this? How many have we written? We've written 4 or 5. How many points have you written so far? I mean, what's the number? What number is this one? I mean, you wrote 4. This should be 5 now. 5. Then this is 0.6. Then this is 0.7 for neutrality. Okay, if you are done with that, we'll go to the next part. Are we there? Can I continue? Okay. Now the next thing you need to take note of is if pH is negative log 10 of the concentration of hydrogen, it means pOH. Ma? Okay. That's this one. Okay, so before you write it, just write for a solution to be neutral. To be neutral, conc of this equals this, or conc of this equals this. Therefore, this times this will give this. And so put that down. for a solution to be neutral, then you write this. Okay, be fast about it. Are you done? KW is equilibrium constant, ionic product constant of water. You get, so that's that. Okay, now let's take this all out. Okay, so let's continue. So where was I? I said okay, let's continue, don't mind me. I said if you know that pH is negative log to base 10 of the concentration of hydrogen, it means that pOH will be negative log to base 10 of the concentration of hydroxide ion. It makes sense, right? Good. And it still describes acidity or alkalinity, but in a different sense. This time around, you are using the OH to calculate. Are you getting what I'm saying? Now, if you are given a base, just you can put it down. Now, once you are given a base, solve for pOH. Once you are given a base concentration, solve for pOH first. Once you are given a base concentration, solve for pOH first. It's easier to solve it that way. And if you are given an acid concentration, solve for pH. If you are given a base concentration, solve for pOH. If you are given an acid concentration, solve for pH. It's easier that way. Now I'll tell you why. So why did I say this? Before we get to that, let's talk about point 9. Point 9 will now mean that if you are asked to find the concentration of hydroxide ion, it is going to be 10 raised to the power minus pOH. You agree, right? Okay, good. So 10. Now, why did I say find pOH first? Because it's easier to find pOH with the concentration of hydroxyl ion when you have the hydroxide ion. So you find it, then you now use this relation to find pH. pH plus pOH is equals 14. Which means if you have pOH and you're looking for pH, pH will be equals 14 minus pOH. Which means that pOH will be equals 14 minus pH. Is this clear? Okay, very good. So with that said, I presume this is fully understood. Then we go to the next point, which is the 11th point. 11th point is pOH less than 7 is the opposite of pH. Are you listening? So if it's less than 7, will it be alkaline or acidic? Yes. Yes. Remember, it's the opposite of pH. Exactly. Alkaline. If pOH is greater than 7, what will it become? Good. If pOH is equal 7, it will be neutral. Do you understand? Good. So take note of this. These are the 11 points that once you understand, you will be able to solve virtually every pH or pOH question in your level. The other point I wanted to mention, is that concentration of an ion, let's say hydrogen ion, is equals the concentration of the salt multiply the acid or base multiply. Okay, this is acid. Sorry, concentration of an ion is equals concentration of the acid times what we call dissociation, degree of dissociation. But I don't think we need that. No, you don't need it now. Don't worry. Forget about it. Don't worry. But then you could just take note of it, You get concentration of hydrogen ion is equals concentration of the acid times degree of dissociation. Basically, and give you one other question to solve. Now, remember, did you write that? Okay, let's look at the question. The question says a sample of orange juice is found to have a pH of 3.8. I like writing out my parameters. So, orange juice is excuse me, come in. So the pH of an orange juice sample is 3.80. Now let's look at the question. So they now said, what is the concentration of hydroxide ion in the juice? So we're looking for conc of OH in the juice. Now this is very simple. I told you that you use pH to find two things. Are you listening? You can use pH to find pOH. Hope you know. And you can also use pH to find the concentration of hydrogen ion. Those are the two things you can use pH to find. So we can decide to use this angle or use this angle. Are you getting what I'm saying? Now when you want to find OH minus, there are two things you need to find OH minus. Number one, you can use pOH to find OH minus. Number two, you can use concentration of hydrogen to find OH minus. So that's basically why you can use two methods to solve this question. Let's use method one. Method one is using pOH. Now if you remember, concentration of OH minus is equals 10 raised to power negative pOH. Is it not? Are you still with me? Which means if we have pOH, we've gotten our answer. Now how do we find pOH? pOH is equals 14 minus pH, and we have the pH in this question, which means 14 minus 3.8 will give us pOH. Okay, what's 14 minus 3.8? That's supposed to be 10.2, right? It's done. Good. So we have that the pH is 10.2. Therefore, our concentration of OH minus is going to be 10 raised to power minus 10.2. Okay. Use your calculator. Punch that. 10 raised to power 10 raised to power 10 raised to power minus 10.2, and your answer 6.3 times 10 raised to power minus 11. This is, let's use method 2. So using method 2 is where we use concentration of hydrogen to find OH. Remember, concentration of OH is equals 10 raised to power minus 14 divided by concentration of hydrogen ion. Are you still with me? So the question is, how do you find the concentration of hydrogen since you have pH? It's very simple. If you are looking for the concentration of hydrogen, is it not going to be 10 raised to power negative pH? Shall we? So concentration of hydrogen ion is going to be 10 raised to power minus 3.8, and if you do that, we'll get our concentration of hydrogen ion to be what? What's your answer? 10 raised to power minus 3.8. 1.5 times 10 raised to power 58 times 10 raised to power minus 4. Okay, good. So if we now put this in our formula to get OH, remember we're not looking for H, we're looking for OH, divided by 1.5 times 10 raised to power minus 4. Okay, so do that. 10 raised to power minus 14, 10 raised to power minus 14 divided by 1.5 times 10 raised to power minus 4. Please, what is your answer? Now please, 1.58. Exactly, so it is still right? So which method is easier? I think the pOH method is easier, because it's minus. Do you get which one do you think is easier? Exactly, it's straightforward. Just do this and this. So just know